The biggest thing to do when solving a word problem using proportion is setting up the fractions correctly. You're going to have a fraction on either side of the equation. The top numbers need to be talking about the same thing, and the bottom numbers need to be talking about the same thing. Really, you're going to pull this information from the word problem. In these two examples, we're going to be given three numbers, and then we'll just find the fourth using cross multiplication to solve the proportion. But sometimes we're not going to be actually given the three numbers. We need to find some of these, but we always need to focus on what three numbers we have and what fourth number they want us to find. The question is really the important part of this. So these two are going to be straightforward. After that, we really need to focus on the question. The first one says, during a rain delay, tarps need to be rolled over the baseball field. One tarp can cover 2,700 feet squared. How many tarps will it take to cover the 8,100 feet squared infield? So we're talking about the number of tarps that can cover some area. We have one tarp covering 2,700 feet squared. And then the question, again, that's really the important part. How many tarps will it take? How many tarps will it take to cover this area? We're comparing tarps to the area. A lot of the times we want to look for the units because that gives away what a number means. Feet squared always means area here, so we actually can write that either way. So the first relationship they give us is that one tarp covers this much. One tarp covers 2,700 feet squared. The second part, they tell us part of it. They tell us that we're trying to cover this much, but they don't tell us how many tarps we need. This is how we're setting up our proportion. To solve this, we're going to cross multiply. We're going to cross multiply 1 times 8,100, that's just 8,100, and 2,700 times x is this 2,700x. We could put these on either side. It really doesn't matter. Our last step to solve for this x needs to be to divide by this 2,700. We're going to do that on both sides. It cancels out over here. On this side, we'll just be left with 3, and that means it takes 3 tarps to cover that much. There's two really easy ways to check ourselves. One, just plug back into the proportion here. You can either cross multiply and you should get the same number. You could do that times that and this times 3 and you should get the exact same number. Or you can divide this fraction out. 1 divided by 2,700 will give us a decimal. You should get the exact same decimal from this. 3 divided by 8,100 should give you that same decimal. Another way to check yourself, just using some common sense, does your answer make sense? Is this 3 times more area than that? Basically, would it take 3 of these to cover that? Does that really make sense? And here it should. If you were to set your proportion up wrong, if you flip this around, you would really get an enormous number because you'd do 2,700 times this number, and that would be your x. That wouldn't make sense. You should be able to use some common sense to rule some answers out. Number 2 says a cookie recipe calls for 1 1/2 cups of chocolate chips to make 24 cookies. How many cups of chocolate chips would it take to make 110 cookies? So we're talking about the number of cups of chocolate chips it'll take to make this many cookies. The question is saying the exact same thing. That's why these are straightforward. It's, again, cups of chocolate chips to how many cookies it'll make. That's going to be our word ratio here. That's what we're comparing, chips to cookies. The first relationship they give us is 1 1/2 cups. 1.5 cups will make 24 cookies. We don't know how many we'll need to make 110 cookies. Again, we're going to cross multiply 110 times 1.5 and 24 times x. That'll leave us with 24x equals 165. That should say 24, not 224. Our last step is going to be to divide by that 24 on both sides. That'll leave us with nothing there, just the x, and 6.875 on the other side. Most of the time, if the word problem is going to give us a fraction, the answers are also going to be fractions. Also, when we're talking about a recipe, if we're talking about cups, that's really going to be a fraction also. That's not going to be a decimal. So we just have to know that in the multiple choice options, that matches up with it. Or if we need to write this as a fraction, we need to convert it to that. Most likely they won't make you do that. You'll just need to match up this multiple choice option with your decimal. Just divide this fraction out. 7 divided by 8 will give you that decimal. Again, you want to make sure that this answer makes sense. We're making a lot more cookies. We're making about 5 times more cookies. So we should get about 5 times more cups of chocolate chips. That makes sense. The next set of problems, we're actually going to need to find some of the three numbers. We don't have all three numbers right away. It might look like we have the three numbers that we need, but we can't just set up the proportion using those three. We're going to need to find the third one and then move from there into the proportion and solve for the. Number 3 says the Atlanta Falcons won 5 games and lost 1 game. If they keep at the same pace, how many games would they win if they played 36 games? All right, so first off, the question is the most important part. That's what we're going to look at. The question is talking about how many wins they're going to get in some number of games. That's got to be our proportion, actually. That's got to be our word ratio, the number of wins to games. Then we're going to look at the other information. We're going to see how we can find this from that. So we have the number of wins directly. They won 5. That's part of our info. We also know that they lost 1. Well, if they won 5 and lost 1, they don't talk about ties. We're going to assume that that's their total games. They played 6 games. All right, so even though they didn't outright give us the number of games here, we have to know that they won 5 and lost 1. That gives them a total of 6 games. So that's really the information we're given here. 5 wins compared to 6 total games. They're telling us that they're going to play 36 total games. We want to know how many wins they're going to have there. So they're winning 5 out of every 6. We want to know how many they're going to win out of 36. We cross multiply. 36 times 5, that's 180, and 6 times x, that's just 6x. We divide by 6 on both sides, and x is 30. So they win 30 games out of 36. Again, does that answer really make sense? Yeah, I mean, they're winning most of their games. 5 out of 6 is pretty good. 30 out of 36, again, that's pretty good. That's most of their games. You could also divide that fraction out. 30 divided by 36 is the same thing. That same 0.833 repeated as 5 divided by 6. You could also think about this as playing 6 times the number of games. They multiplied this number by 6, so that number was also multiplied by 6. What it is as decimal, and that's how it can be written as a fraction. Number 5 says that our last test had 30 questions. If you got 80% of the test questions correct, how many questions did you get correct? So, like I said, we're always going to put the percent over 100, but this actually also helps us set up the rest of this proportion. The percent is talking about, in this case, how many we got correct. The 100 on the bottom is talking about all of the questions. That's always the total that we're talking about. This is some part of that total. So this is questions correct compared to just the questions in general. We're told that we got an 80%, that's 80 out of 100. That really represents the decimal 0.8 or 80%. That is just 80%. We're just putting that into a fraction. And then on the other side, we're going to compare that to a total of 30 questions. We want to figure out what that 80% correct is out of the 30 questions. Start off the same way. We cross multiply. 2,400 equals 100x. Our last step is dividing by this 100 on both sides. That gives us 24 correct. That makes sense. 24 out of 30 would give us 0.8 or that 80%. And that makes sense. It's a good chunk over half of this. If you get a number bigger than 30, that can't possibly make sense. If you get a decimal, that also can't possibly make sense. You need to be getting a decent number correct to get an 80%. So that answer does make sense. Number 6 says the library has a total of 6,075 books. If 2,225 are checked out, what percent of the books are not checked out? Okay, that's important that we read that last part. What are not checked out? So here they're giving us how many are checked out. We need to find how many are not checked out. So again, percent over 100 is going to help set up the rest of the proportion. What are we really talking about? What percent of the books are not checked out? We're talking about that, not checked out, compared to the total number of books. All right, so here they tell us that many are checked out. We're going to subtract these two numbers to figure out how many are not checked out. Those are the number of books that are left there. This number, 6,075, minus 2,225. That tells us the number of books that are not checked out of our total. We don't know what percent that is yet. That's going to be our variable out of 100. This is always going to be 100 beneath the percent. Our first step is cross multiplying. Multiply here, we get just that as the coefficient, 6,075. And here we multiply, really just adds 2 zeros onto that. Actually, that means we need a second 0 on there. And our answer kind of just popped up there, but we're going to go with that. So our answer is 63.4%. Our last step was to divide by this number, and we get 63.4. That should make sense. It shouldn't be bigger than 100. It can't be more books not checked out than total books. It should be a good chunk of them. It's over half. This should be over 50%, so that answer makes sense. Now we're going to be using proportions to solve problems involving pictures and graphs. So here we have a pie chart, and it's talking about David polling people at the mall to determine which type of movies they prefer to watch. So letter A says, of the people polled, 210 preferred to watch comedies. What is the total number of people David polled? So we're talking about this group, this 35% that liked comedies. There's 210 of those people, and we want to know what's the total number of people polled. So we're comparing the number of comedies to the total people polled. Really, that's coming from the question. What's the total number of people polled? We know that we need to use comedies here because that's the only other information we're given. 210 watch comedies, and we're given that 35% like comedies. That percent is a giveaway for part of our proportion, 35 over 100. The next part of the proportion is really what we're trying to find. We know that 210 liked comedies. We're going to line that up on top. We don't know the total number of people. That's what we need to find. So we're going to cross multiply 35 times x. That's 35x, and 210 times 100. That's 21,000. We divide by 35 on both sides, and we get 600 total students. It needed to be a number bigger than 200. If it was smaller than 200, that's a dead giveaway that we set this proportion up wrong. If you put the 210 on the bottom, you'd get a number smaller than 210. So that makes sense, and at least that way, again, you could just divide this. Just check that. 210 divided by 600 is 35% or 0.35. The second one is asking if a total of 1,500 people were polled, how many preferred horror movies. So this is similar to this previous one. Now we're given the total people. All right, so we're told the total on the bottom, and we're asked about the number of people that like horror. Well, we're told that 5% like the horror, so we know that's going to be 5 over 100. We always put the percent over 100. On the right side, we're going to have x over the total. We don't know the horror people, but we know the total people. And we know that that's 5% out of the total people. We're cross multiply here. 5 times 1,500 is 7,500. And 100 times x is 100x. We divide by this 100 as our last step. And we find out that 75 people liked horror. Again, just to check to make sure that answer makes sense. 75 out of this fairly big number, that makes sense as 5%. You could also divide it and you get 0.05. All right, example 2, we have a bar graph that's talking about Dr. Nussbaum's class and their favorite pets. So we have 3 that like dogs, 4 that like cats. This is a pretty small class. 2 that liked fish, and 1 that liked a hamster. So we want to figure out what percent of students said that a dog or a cat was their favorite pet. So we're talking about these 2 bars, dog or cat. That's 3 and 4 here. We're asked what percent of students. That might be trouble here. I don't see any percents. So we know we're going to have to set up our equation, our proportion, using a percent over 100. We don't know what that percent is. That's actually what the question's asking. But we know how to find a percent. It's always some part out of the total, some chunk of them out of the total people. So here we have a total of 4, 3, 2, and 1. Our total is 10. This number on the bottom. And our top number, the percent that we're trying to find, is the people that like dogs or cats. That's this 3 plus 4 or 7. All right, so we're comparing the number of people who like dogs or cats to our total. Here that's 7 to 10. And we are given this bottom number always, that's 100, and we're trying to find that percent. You might actually just know what this is as a percent. That's just 70%. You could just divide that out and change it into a percent that way, or we can cross multiply 10 times x, that would give us 10x, and 7 times 100, that's 700. We divide by 10 on both sides, and we get 70 people, or 70%. I should say percent. Like dogs and cats. It's very annoying that it resizes that every single time. Alright, so 70% like dogs or cats. That answer does make sense. It's a good chunk of them. It's over half, so that one's good. The next part of this says that the whole school was surveyed and the proportions remain the same. So the proportions from this will remain the same for the bigger population of the school. If there's 500 people in the school, how many did not say hamster? So it's going to be a lot of them. It's going to be most of them. We're looking for how many people are not going to say hamster. That's what we're comparing. How many people did not say hamster to the total number of people. Here we see that that's 9 out of the 10. It's dogs, cats, and fishes all together. That's 9 compared to the one person that said hamster. You could also find the number of people that actually said hamster and subtract it from the total. We're going to just find it directly. Not liking hamsters to the total is compared to not liking hamsters to this new total of 500 people. You cross multiply, and we get 10x equals 4,500. And we divide by 10, and we find that 450 people liked not hamsters, other things other than hamsters. And again, that should make sense. That's most of this 500. There's just the 50 people left that do actually like hamsters. So that makes sense. Example 3 is a scale drawing of a map. This is a really common type of problem. They're going to give us a scale drawing of a map, and they're going to say that some number of inches or centimeters, some small measurement relates to some bigger measurement, miles or kilometers in real life. So some measurement on the map compared to some measurement in real life. Here we have a map of North America. It's talking about 2.5 inches on the map representing 150 miles in actual distance. That's our scale. That's definitely going to be one of our fractions. Anytime they compare units directly like that, that's a pretty good giveaway that that's going to be a fraction. Inches compared to miles. Or the map distance compared to the actual distance. Both of those are going to mean the same thing. If Green Bay is 3.25 inches away from Chicago on the map, how far away are the two cities in miles? How far are they away in real life? All right, so we know one of our fractions is going to involve this 2.5 or 2.5 inches compared to 150 miles. That's our scale. We're given this distance in inches. That's going to be on top. That's what we're comparing on top. Inches to the number of miles on the bottom. So it's 3.25. That's 1/4 as a decimal over some number of miles that we don't know. We cross multiply. 2.5x equals 487.5. And we divide by 2.5. We find out that they are about 195 miles away from each other. That should make sense. Again, 2.5 going up to 3.25. It's just going up by a little bit. So that should, again, just go up by a little bit. It's going up from 150 up to 195. Should be a little bit more.